Greetings and welcome, friends. Mr. Waddy and my fellow geometricians. We're hanging out talking about proving triangles congruent side angle side, which is going to be way better than trying to prove them congruent by showing that all of their corresponding sides and angles are congruent. It's going to be a lot less if I only have to show 3 pairs of things congruent, 2 sides and their included angle. Keyword included right there. So let's check this out. It says name the included angle between the pair of sides given. So PK and LK. Here's PK and LK. The included angle is going to be angle PKL or LKP. All right. I can't just refer to that as angle K because there's this angle, and there's that angle all at that vertex, so that's not sufficient. Let's see. How about for the next one, KP and PL? KP, PL. That one I just could refer to angle P because it's the only interesting angle at that vertex, like so. All right, here we go. Guys, you be careful now, friends. It says decide whether there is enough information to prove that the triangles are congruent using side angle side congruent theorem. Theorem 5. Plain. All right. Let's label what I know. I know this is congruent to that. I know this is congruent to that. And I know this is congruent to that. The answer? No. What's the included angle, friends? Yeah, this angle. If I knew this angle and this angle, then I could have proven it congruent by side angle side. We actually, never mind proving by this theorem, I can't prove those are congruent using any theorem. Because what I have is some sort of angle side situation, and there's no angle $sign theorem for proving triangles congruent in the world of mathematics. Does not exist, and not just because mathematicians like myself are proper in our language. But no, it just doesn't work. In reality, in pre-calculus, you might realize you got a 50-50 chance of being right. It's called the ambiguous case of the law of signs, which also be a great Harry Potter subtitle. Here we go. EFH, congruent to EFH. Okay, yeah, the 2 little triangles. So I've got a side and a side, and what do you guys see jumping out at you? What's some more information here that you could tell me that is not yet labeled? Yes. Yeah, it's congruent to itself by reflexive, and then yes, right, by side angle side. So yeah, reflexive property will let me do that. And let's see, KLM and MNK. All right, I'm seeing some reflexive here. I've got parallel lines cut by a transversal. I could show this angle congruent to that angle. How? Alternate interior angles theorem. Can I prove this angle congruent to anybody? Not yet, no. I mean, if I extend these, I'd be able to have proven it congruent like this, but that's not, yeah, not enough. Not enough. And if you notice the situation I've got an angle. As I move around any of one of these triangles, it's either side angle or angle side. The angle's not in the armpit of those sides. The answer is no, once again, because that's not a theorem. Not allowed. All right, here we go. Let's write a 2-column statement. Here we go. Let's label some of our stuff here. Up there. So I know PQ bisects SPT. You know what? Watch how lazy I am here. That's sneaky right there. And yeah, there's technically 2 that we're given. I listed all of them. So I'm gonna say angle SPQ is congruent to angle EPQ, which it looks like that's what's labeled there, but I'm going to try to restrict myself to what they told me was. How could I take this information and conclude that information? Def of angle bisect, specifically, because there's also segment bisect. So now I know these two angles are truly congruent to each other, right? And what else can I say here? Yeah, that's the one that's you guys are going to get so used to, it should just jump out at you. That's true by reflexive. And looks like I've got 3 pieces of information, 2 sides and an angle, and it's the included angle. So I can say triangle SPQ is congruent. I think that's the best triangle I've ever drawn. Like, look, they usually look like that or worse. TPQ. And that's true by side, angle, side. So yeah, it's oftentimes a matter of finding that extra information and then restricting yourself, recognizing like, all right, it's got to be side, angle, side. I can't have angle, side, side, like that. All right, here's another common one that'll show up. Statement, reason, here we go. Uh-huh. All right, now they've once again got this information labeled, but I technically can't say that just yet. I'm going to try to justify it. I'm going to say BC is congruent to DC, as well as AC congruent to EC. Same reason for both of them being ish. Yeah, they technically told me it was a midpoint and not a segment bisector. Def of MP right there. So I've got that. It's only pairs of sides, friends. What else? Yeah? Vertical angles theorem. That one should definitely be jumping out at us. Like so. And the arrangement of these letters here are perfectly sufficient for talking about angles, but they wouldn't be sufficient once I go into the world of triangles, because I realize these are kind of like flip-flop triangles of one another. So yeah, so it's sufficient for this, but I can't get away with that for triangles. Fortunately, I can just steal theirs as my last step. Triangle ABC is congruent to triangle EDC. And right now, I mean, kind of the main only reason we'll be using is side angles. Jesus. All right, I'm going to verbally walk us through this one, I hope. It tells me that this is a regular pentagon. All right, so let me label what that is. So that means this, and this are congruent by, like, definition of regular pentagon. Technically, definition of equilateral pentagon would tell me that. I also know this angle, and this angle, and this angle, and this angle, and this angle are congruent. Also, by definition of regular pentagon. So let's see if I have enough information to prove some triangles are congruent. Yeah, I got this. I think I can prove this one and this one. So triangle 2 is triangle. I started at one of the acute angles. UVR. And the reason is side angle side. Because, yeah, I knew this armpit angle and then 2 sides. Right. As far as what those measurements are? Oh, okay, okay. We did have a theorem about congruent figures. We said corresponding parts of congruent figures are congruent, and that's actually a biconditional statement. So, that will end up building in towards like 5.7, I think, later on in this chapter, in which once I know these two triangles are congruent, I also could then just be like, oh, then all of their corresponding parts are. I would also know that, and I would also know this, and well, in this case, actually, I couldn't have just said that. I could have said this, and then this, and this, and I think we suspect that these two angles are also congruent to each other, and we'll be able to say that with more confidence today after our lesson. Yeah. Yep, but as far as triangles, we don't have any more triangle facts. All right, let's see how we can do on this construction. I realize your guys' construction was a little bit different. But I'm noticing here that this looks like a 140-degree angle. You guys agree with that? Ish. That's what I got when I measured it, roughly. I've got 40 there, but its supplement is 140. And I'm going to draw something over here. How about let's there's like a thing. I'll call this, I don't know. Did they give me a name? No, on yours didn't they have like R and RST? Okay, I'll call this R. R to correspond with A. And so here's R, point R, and then some ray coming off of it. And let's see if I can actually successfully move my protractor. And so I'm going to come over here, use my protractor, and I'm going to kind of tick mark at 140. Oh, you know what I just did? I did my classic mistake. I actually wrote on the same layer as my protractor. Ugh. There we go. And now let's draw a something like, right? I think I don't need my protractor anymore. I just needed to copy that angle. Actually, guys, we know how to copy that angle. Well, body. We could have done this without a protractor. I was just thinking. You guys think so? I actually, right now, I'm thinking in my brain, I don't remember how to copy an angle, but I think if I throw enough arcs at it, it'll work. All right. So, all right, let's see what I can do. I'm going to go to my compass tool. That's an ellipse. All right. And I'm going to duplicate the angle. I'm not duplicating AC. I'm going to choose some different thing like that, okay? And I'm going to give myself plenty of overlap, something like. And now, what do I have to do? I feel like I'm bisecting an angle here, guys. Oh, yeah. I put it at one of those intersections and line its distance up to intersect over here. And if I do the same thing, I know I'm doing it from the other side here in this case, but it doesn't matter. Either way, I get a point. And I can now draw like so. Yeah, I didn't even need a protractor. There we go. So I just duplicated that angle. Actually, tell you what, let's see how well I did. Boy. Even. Well, it kind of, works. If I was a little bit more accurate, but there we go. Either way, I've got that first angle. I duplicated it one way or another. Now I want to just duplicate two side lengths, and that's just going to be a compass tool, right? So I'm using side angle side. So I've got the included angle. Now I've set my compass to be AC units long and line it up here. No? All right, yeah. And this point will be the same as S, call it. All right, there's point S. And let's match the other length. So this is constructing congruent segments, right? That's going to be my side angle side, right? The two S's in side angle side. So let's make this AB units long on this one. Color. And I could do that over here. And kind of doing this twice, but that's fine. And here will be point T for us. Right? And now I should be able to, in theory, connect the dots and be done with it. All right, let's. And lovely, lovely, lovely. Thing of beauty. So I'm duplicating this triangle. I'm constructing it using side angle side. Notice I didn't do any constructions for any other angles or other sides. I'm letting the theorem do the heavy lifting for me. So I only duplicated 3 values, right? 3 measures are identical. 2 segments and 1 angle are congruent. And I'm assuming that these other angles, right? This angle is going to be congruent. This one, this angle is going to be congruent. I guess more specific. Right? And I'm also assuming that this segment is going to be congruent with that one. And it should be, because the theorem is true, I told you. And I think we kind of proved it today. I think so. Well, anyways, thanks for watching, internet friends. Adios.